Well, we have Seymour Bones with us today, and we're going to talk about some really we're going to talk about some of the human anatomy things that we look at and that we study. But I want to show you some of the things on on Seymour here. So when we look at the skeleton, of course, we see the bones, we see the cartilage, we see a lot of different things. But we're going to start out with the skull here, and I'm going to have my expertise camera person zoom in on a few things. So the first thing I want to show you is where the skull comes together here, and so we want to look at these. We want to look at these sutures right across here, and this is where we start out with. The soft spot on the brain, and the brain goes together and kind of fuses itself in there. So hopefully you can see that a little bit. And then when we get inside of the skull, while we're zoomed in, let's look at this. And it's really amazing the cavities that we have in there. This is actually the sinuses. And when we look at the sinuses, it's really important because we actually have holes here, and this is kind of neat. We have holes where we actually take air in and we take air out. And what we're trying to do here, the purpose of the sinuses is try to control the temperature so the air going in is not real cold or real warm. We're trying to get that about 98.6 to go into the body. So then the other thing we have, we talk about foremins and sinuses and holes and openings, and we've got a lot more of those terms to go. But as we look at those, every time there's an opening, then we're going to have some type of duct, or something that goes through. So these are called sinus ducts, and then we actually have, it's kind of interesting, I don't know if we can see our tear ducts. And I've got an excellent person on the camera today, and so we can actually see our tear ducts. And then we have our eyes. We have our ocular place where our optic nerve goes in, and then we look, and then this is the opening for the actual spinal cord. So it's interesting when we look at this area. Of course, the brain actually sets and rests right here, what we call the brain stem, and we see two big openings here that the brain actually pushes on. And so these big old indented places here is where the brain actually sets and the brain actually rests. And it's kind of interesting because then as the brain rests, it goes there. But then when we look at the top part here, and as the brain comes up over the top, we don't see a resting point. Instead, we actually see a real rugged spot here, and that's because we have to allow, when this rests back here, it rests solid, but up here we actually have to allow, there's an air pocket in the brain. It's fascinating, We talk about athletes getting concussions or people getting concussions, and the air pocket is a big part of that. So what we actually do here is we actually allow for air in here, and there's actually a temperate area in the frontal part of the brain, and we see where we have an opening here that actually allows. That's why we check the temperature on our forehead. A lot of times we'll check the temperature on our forehead because this is actually a temperate control area for the brain, and we'll have spaces in here where the brain sets. So I just wanted to show you a little bit of the inside of the brain. You'll see a lot of this on your ID test, but I just wanted to show you that. So then as we get to we put this skull cap back on here, all right, and we put this back on. And then we see on here also, we see our zygomatic, our cheekbone. We see the area there, and then we see how important it is, because what it does is it also separates an area for our sinuses. And then when we look at the bottom, we look at the bottom. We talk about somebody who, I don't know if that's kind of tricky to see there, but we talk about the septum there. We talk about somebody who has a connected septum. It's not separate there. So we have to be able to allow air to come in. Once again, everything is packed into the sinuses. So kind of interesting there. I wanted to show you a few things there on Seymour. I want to show you a couple more things. I'll move up a little bit. Of course, you have your atlas vertebrae. You have your atlas vertebrae. We have, and I'm going to try to not, because as we inject this, we're going to inject this a little bit early into where we're going to put everything. So I'm not going to give you all the names for everything at this point. I want to just kind of show you some functional things, and so rather than make this video really long, we're gonna just show you some of the functional areas. So on the atlas vertebrae, we have something really interesting. Okay, we have something really interesting, and we have two little holes right here. Okay, we have two holes. Now that's kind of cool. Okay, that's kind of cool because as the skull fits on there, okay, as the skull fits on there, we find that and once again, it's just amazing. It's just amazing because this isn't our human skeleton. Everything has a function. Every little bone, we're like, wow. Well, what does this little extension of a bone do right here? Well, it's kind of cool because when the skeleton goes on, okay, those actually fit into that part of the atlas vertebrae, the top vertebrae, and we'll put our little deal in here to hold us here so we can see the rest of this. All right. And actually, let me leave this off. We'll look at a few things. But that actually fits there. And what does that allow us to do? It allows us to be able to rotate our head side to side, but not be able to go all the way around. So that's where we have our spinal cord in here that we don't want to extend all the way around. Okay, so that allows our head to go back and forth, but not all the way around because we're connected into those holes there. So that's kind of cool. So then we have a common name, Adam's apple. We'll learn a little more what that is, and we're actually gonna protect our larynx right here, our voice box right here. And so that's what you're actually feeling when you feel your Adam's apple, is this little extension of a bone. So it's really incredible because as we develop and as we grow, every little part of the skeleton is amazing. Somebody that doesn't have these little extensions, or these holes aren't just right, then their head doesn't rotate properly. Somebody that doesn't, if their Adam's apple here is not extended to the right amount, then their larynx has either too much space or not enough space. So that's amazing. Okay. So once again, a lot of the things that we're going to talk about today are just kind of in general. We want to point out some things that you'll see later in the class, but I just want you to begin thinking about how the skeleton is actually put together. So when we look at the sternum, okay, it's really important. Okay, when we look at the sternum, we have the xiphoid process. Now, this xiphoid process, okay, now remember, other than the skeleton, we're going to have the lungs setting back up underneath here. So this xiphoid process, when we do CPR, okay, and we put compressions on the sternum, okay, the reason that we find that xiphoid process, and then what do? We count up 2 fingers. I don't know if anybody's been trained in CPR, but we go 2 fingers up. We find the xiphoid process, this pointed bone. We go 2 fingers up, and then we put the compressions on. Well, that's really important because somebody that doesn't do that might put the pressure on the xiphoid process and begin to push. And if they break that xiphoid process, where's it going to go? Well, what happens is that bone doesn't break off because it's connected by all this cartilage. Instead, what happens is that bone bends backwards. So here's this pointed bone, the xiphoid process. So as we do CPR, what do we do if this bone's pointed backwards? When we damage the lung, we keep rupturing the lung, and so that's why that's so important. Okay, so then as we're looking at this, okay, we look at the cartilage, we look at the true ribs, and we look at the false ribs. So as we look at the ribs coming down, we look at the cartilage that connects it. Okay, and then I want to show you because when we talk about floating ribs, we see what we call true ribs. Okay. We see the true ribs, the white is the bone, the plastic is the cartilage. But what we don't see, okay, and what I wanted to show you are these floating ribs. Now, these floating ribs aren't very big, okay? Of course, there's a piece of wire to hold them on here. But as we can see, these are the floating ribs. And we have 2 pairs, 4 floating ribs, 2 on each side. And as we can see, they're smaller areas. So whenever we talk about organs in the body and we say those are protected by the floating ribs, okay, from impact from the back, okay, all right, then you begin to see that they're exact shapes of the organs. Isn't that amazing? So we have exact shapes there that allow us to be protected. Now, what's protecting us from the front? Well, we have the rib cage, but we say, well, what's protecting us? What's protecting these organs from the front? Well, those are your abs. Your muscles that are right here are your actual protectors. So when you're hit, it protects those organs. So we have an incredible amount of armor. We have an incredible amount of armor on the back. Okay, of course we have the scapulus, okay, the shoulder blades, and as we look at direct areas. Now this acts like a shock absorber. So whenever we're, at all costs we want to protect the spinal cord. Okay, at all costs we want to protect the spinal cord. Now, even though we have these incredibly large vertebrae and we have all the, we talk about the different spines that come off of those, the different parts of the vertebrae, the actual spinal cord is about the size, if you think about the pencil lead that you take out, it's not much larger than pencil lead. Isn't that incredible that all of this is protecting, you know, like the lead that you put in a pencil, your actual spinal cord is not a lot bigger than that. It's about the lead of a regular lead and a lead pencil. So isn't that amazing that all that's protected? But we have all this to where it can bend, okay, and still protect. But what happens if we get hit? What happens if we get hard? What happens if we fall off the roof? What about all this vibration? This is amazing, okay? This is amazing. So all of this vibration, okay, even from the front, okay, even from the front when we look at the clavicles, okay, we look at the collarbones, all of this is attached, okay, and all of the ribs are attached to the scapulus. And so what happens is they take all of that shock. And all of that energy is actually absorbed into these bones. Now, not that these bones don't absorb some energy, but they absorb a little bit. So these act as shock absorbers. So that's pretty amazing. That's pretty amazing. Now, also I want to show you when we talk about the different types of vertebrae, I want you to see the shape of the vertebrae, the lumbar, the big, large lumbar vertebrae. How big, okay, how big the lumbar vertebrae that have to support the weight of your body, okay, and then we have the cervical and the thoracic, but I want you to see the size. See, it starts out really small and goes down into really large. Now, when somebody is having some back issues, okay, and they say that their vertebrae are grinding, it means that this cartilage is worn out. Okay, so let's look at that for a second, and I really like the scientific accurateness of the skeleton, okay, because we can see it's really proportional how large it is on the front, okay, for the cartilage, okay, that once again is a shock absorber, but also keeps the vertebrae off each other as you bend. But then when we look at the back, what's amazing is we don't have cartilage on the back, okay, look at this. We don't have cartilage on the back. Instead, the vertebrae lock into each other like a piece of a puzzle. Okay, so isn't that amazing? Isn't that amazing? When we look, we have the cartilage that goes up behind, but these allow for the connection, and all of your cartilage. It does go nearly all the way around this thing. Okay, we also have the connection of the spine. Now, we're going to come back with another skeleton video here, so I'll see you for the next one.